Hello, it is Mr. Chai here. So today we will be going through worksheet 22.4, so please make sure you have it in hand. This video will focus on the working principle of the AC transformer. So you will need this worksheet to help you jot down some notes. So in the SLS exercise, I assume that you have already familiarized with the different parts of the transformer. So I will start from the beginning on how this transformer works. So in a transformer, you will have to have an AC source. So what it does is that this AC source will be connected to a coil. So over here, it will be connected to a coil. So when the AC source flow through the primary coil, it will produce a magnetic field, right? So this magnetic field that is being produced does not have a fixed pole because of the alternating nature of the current. So at one instance, it will have a north pole here. At one instance, it will have a south pole here, and then it will swap. Right, that is the nature of an alternating current flowing through a solenoid. So if you want to describe this, this is what we call an alternating magnetic field. Right, so it will produce this alternating magnetic field, and because it has a iron core over here, this magnetic field line that should looks like a spider like that. I don't know whether you call it a spider or not, but the typical magnetic field line will be all spread out, right? But due to the iron core, because the iron core is a magnetic material, it will actually redirect and concentrate the magnetic field line as shown in this diagram. So it will go along the contour of the iron core, and it will concentrate the field line towards the secondary coil. So just to recap, in the primary coil, I have an AC source. The AC source produces an alternating current that flows in and out of the solenoid, and because of that, it will produce alternating magnetic field, and this alternating magnetic field will be directed by the iron core and towards the secondary coil. So if you look at the secondary coil, you will see that it has no electrical source. It is just connected to a load, right? And of course, this secondary coil, it is insulated from the iron core. Okay, so actually the secondary coil is just a piece of wire that wrapped around the iron core. And of course, the wire has plastic webbing. So actually there's no current or whatsoever going from the primary coil through the iron core and then go into the secondary core. They are all three isolated pieces. So this primary coil, soft iron core, and this secondary coil, they are insulated from each other. So there is no electrical contact between them. Okay, so earlier on I was saying that the alternating magnetic field line will be redirected and concentrated by the iron core and into the secondary coil. So this secondary coil basically is a conductor, right? So because of that, Faraday laws will kick in, right? So this secondary coil will be the conductor that actually experiences this alternating magnetic field coming from the primary coil. And as a result, according to Faraday's law, there will be an induced EMF produced across the secondary coil. So this induced EMF will be then able to power up this load. So later on, I will be sharing with you the equation that governs this transformer. And due to the different number of turns in the coil, what we can do is that we can control the ratio between the number of turns in the primary coil versus the number of turns in the secondary coil. And we use this ratio between the number of turns in the secondary and primary coil. We can actually adjust the input voltage and the output induced EMF. So the ratio will actually affect the output, the size of the output induced EMF, and as a result we are able to moderate or regulate the voltage that we want. So for example, we have a 240 volt supply, but we can use that to charge our phone, which can take up to like 20 volts, right? So that is how a transformer work. So let's do a quick summary over here, and you can now go back to SLS. The answer will be revealed on the SLS.